We worked with a client that needed to improve their delivery truck loading operations. If the firm has unused truck space or is wasting time trying to determine how to effectively load them, it leads to inefficiencies for the company and longer delivery times for their customers. We found that there are basically two primary operations when deciding how to fill a truck. First, they must determine the number of pallets required to fill an order. Then one needs to decide the type of delivery truck required for the shipment. We were challenged to develop a model that could predict the number of pallets required to complete an order, then use those insights with various load, weight, and space constraints to develop an optimized loading plan that would lead to more efficient loading procedures. We formulated and tested an optimization model that would tell us the number of pallets required to fulfill an order. We had to incorporate constraints to determine the number of items that can be stacked onto the pallets and the kinds of pallets that can be stacked inside each of the truck while not exceeding a specified weight limit. To obtain more data clarity, we cleaned and joined the information by grouping the items by type, width, height, and total weight to allow the firm to see all of the items so they could easily identify the partial and the full pallets. We went into detail by figuring out whether both pallets were of the same type of good or not. And then we matched them by each item by its root number to figure out the full and partial number of each of these pallets through each of their positions. Once we determined the number of pallets, we were able to identify which trucks were appropriate and how to fit them within a truck horizontally, which led to an optimized loading plan. We then developed a prediction model to figure out the alternatives the company can take to manage any product leftovers. This prediction model that we have created helped us to determine our accuracy rate. Last but not least, with the implementation of our model, we expect to see errors in the trucks decrease rapidly. We predicted 187 out of the 413 routes, but within each of those predicted routes, 44 were not able to load. This was a great start to achieve for the overall future loading goals. The loads were actually similar to the results to their loading practices, which was 71% accurate. We believe once your client takes some time to test and implement our loading solution and benchmark their results, it will lead to an increased throughput of orders in their warehouse.